Hi guys, so this is Vicky again, and we are now going to memorize all the strong and weak acid and bases that exist, just so that we can be able to look at a problem and just like automatically identify if an acid or a base is strong or weak. Okay, so easiest way for you to memorize this is creating a table, um, strong and weak, like so. And I just like to create this table and then just look at it a few times and it'll make your life so much easier. So let's talk about the strong acids. All the strong acids are going to be any proton bonded to a halogen. So HCl, HBr, and HI. Now notice that fluorine is not part of it. So it's all halogens except for fluorine. Okay. Um, if you can just remember this, it'll make your life so much easier. Also, along the polyatomic ions, anyone and everyone that are paired up with polyatomic ions that have a suffix of 8 versus 8, more oxygens you have, stronger the acid it's going to be. So H2SO4, that's sulfate versus sulfite, right? And then HClO3, that's chlorate versus chlorite. HClO4, that's perchlorate, right? And then HNO3, which is nitrate. So if you memorize these, which are what, 7 of them, and you know, like basically all you have to remember is halogens except for fluorine, that makes like 5, right? If you memorize these, everything else will fall under the weak category. So let's talk about the weak ones. So the weak ones are going to be obviously HF, right? Because this one did not fall under this category up here. And all the ones that end with an ite suffix. So H2SO3, HClO, HClO2, and HNO2. Notice how these are all partners. Do you see that? More oxygens you have, stronger they are. Okay, cool. Also, another one is anyone and everyone with a carbon in it. So HCN, H2H3O2, that's acetic acid, that's cyanic acid, cyanide. We have H2CO3, and then any other ones that are considered sugars for the sake of lower level chemistries like honors chemistry and SATII chemistry, but upper levels like college and above, you know that these are going to be weak acids, right? So all the sugars, because see, they all have carbon in their compound. Okay, so all of these are going to be identified as weak acids. So again, if you just memorize the strong ones, everything else will fall under the weak. Okay, all right, now let's continue with the next category. So the next category is the bases. So what about the bases? So if you look on the periodic table, okay, the first 2 columns of the periodic table, right? Alkaline and alkali earth metals. These ones plus a hydroxide is always, always, always going to be a strong base. Okay, so for instance, like sodium hydroxide, potassium hydroxide, right? Lithium hydroxide, all of these are all going to be very, 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 very strong bases. Okay, all right, so that means everything else, all other metals, okay, including transition metals attached to OH minus, is going to be a weak base. So for instance, like zinc hydroxide, copper hydroxide, right? All of these are all going to be weak. Easy peasy. Now there's an exception to the rules. NH3, that's ammonia, right? So ammonia is the only one that you may have to memorize extra, but besides that, these are all the strong and weak acids and bases, okay? Cool. So now let's continue and let's talk about what makes an acid strong and weak, okay? So basically we need to understand how to calculate pHs first. What is a pH? So most of you guys know that pHs are going to be a way for us to figure out if a solution is acidic or basic, right? And we have a scale, and the scale runs from 0 to 14 and 7 being neutral, right? And obviously 0 to 7 is going to be acid, and then 7 to 14, this is going to be base, right? Um, all it means is that closer you are to 0, it just means you have very, very high concentrations of protons. It just means you have lots and lots and lots of H pluses. Okay, it's a very high concentration of H pluses. And as you go, you start losing these H pluses. Okay, so less H pluses you have, it just means that it's becoming a weaker acid. Do you see that? So you have more H pluses closer to 0 and less H pluses closer to 14. Now the opposite is true. So that means on this side you have very low concentrations of H pluses, but you have very high concentrations of OH minuses, which are hydroxides. And on this side, where it's on the 0 side, you will have very, very low concentrations of hydroxides, okay? That tells you that 7, because that's the neutral point, you have the same concentration of H pluses as OH minuses. Easy peasy? Easy peasy. This is why water is neutral, because it has one of each, okay? All right, so if I were to continue, let's figure out how to calculate pHs. So pH, it just means it's negative log of concentration of H plus. So again, this P just stands for negative log and concentration. And that concentration, whatever comes after that P, is going to be in that in those brackets, okay? So what about POH? Same idea. POH, it's negative log of OH minus. Again, that P stands for negative log and concentration. And whatever comes after the P is going to be inside those brackets. Easy peasy? Easy peasy. All right, so here's an example. An example, if I were to say I have 0.0001 molarity of HCl, I know that HCl is a strong acid, so it's going to 100% dissociate into H plus and Cl minuses, right? So that means that if I happen to have 0.0001 concentration of HCl, I know it's going to be a 1 to 1 to 1 ratio, which means that I'm going to end up with 0.001 molarity of H plus. So what is the pH? pH is equal to negative log of concentration of H plus. And where is H plus? It's right here, right? I'm going to plug it in, and if I were to plug it in, what do I get? It's negative log of 0.0001 molarity, which means how many zeros? 1, 2, 3, 4. That's pH of 4. Easy peasy? Easy peasy. So again, super, super easy. So if you understand this, you can actually say, okay, what about POH? Because we know that pH plus POH equals what? 14, right? So this is another formula that you must be memorized. Must be memorized, right? So again, if I said that the pH is 4 and that's 14, what is POH? POH happens to be 10. And that means that because it's going backwards, it's going to be an acidic compound. And HCl, by all means, is acidic.